record. So we're going to do Lewis structure for sulfite. Now, there are multiple steps that you got to take here. I'm going to outline them right now, but in reality, I mean, I would hope that pretty soon you don't need to follow these steps. It should just be sort of like ingrained in your head how to do this. Step one, though. Step one, it's pretty easy. You're going to find the total valence electrons, okay? So find total valence electron count. And I mean, this is not meant to be that challenging. All you need to do, you look it up on your periodic table. So you're going to look it up. You find that sulfur has 6 valence electrons. Are we clear on that?
Yes.
Okay, that's important. I want to make sure we understand that, we remember that. So sulfur has 6 valence electrons. Now, oxygen, if you look it up, how many valence electrons does oxygen have?
6.
6 again, right? Okay. How many oxygens do I have?
3.
We have 3, so 6 times 3. Now, there's one other thing that's not shown on here yet. If you look up sulfite on your ion chart, what is the ionic charge?
-2. -2.
Sulfite is -2. Okay. Now, what does that mean?
There's 2 of them.
It means that there are 2 more electrons, right? Because the negative indicates that it is, there's more electrons than protons. So since we have a -2 charge, we're going to add 2 more electrons to our total valence count. And this is by far the easiest step that people can screw up on, just so we're clear. Okay? You want to make absolutely certain that you remember to deal with the charge. Okay? So
you just add the charge?
Yeah, well, the opposite, remember. If it's negative, you add 2.
Suppose positive, you subtract 2?
Yeah, so if it's like positive, like ammonia is +1, you'd subtract 1 electron.
Oh, I see.
So this total comes out to be, what, 26? 26 electrons?
Yeah.
All right. Now, all you've got to do here, it's pretty straightforward from this point. Step 2 is, we'll say, I don't know, you can phrase it however, but just draw the basic structure. So you just draw the basic structure. Now, what that means, you're going to draw whatever the simplest structure possible is. The way you do that, you're going to be adding little lines that count for 2 electrons. So, what do you think goes in the middle here? S or O?
S.
Why? What? There's only one of them. There's one. It just makes sense inherently that S should go in the middle. So you can do this. Now, a few things. Remember when we did the Lewis dot diagrams, how you say S, and then you've got 4 sides theoretically, right? Where you can put dots. Same thing goes for when we're doing bonding. You've got 4 sides that you can put bonds or electron pairs, etc. So, the way this will work, I don't care if you write it like this. I don't care if you write it where it's like this. It doesn't matter, okay? It makes no difference where you leave the blank spot. It makes no difference. So I just choose to do this. Now, how many electrons do you think I just added into this diagram here?
6.
Why do you say 6?
You said 2 for each line.
So each line counts for 2 electrons. So the way you can think of it is like this. Each line counts for 2. Now our goal is to eventually use all the electrons to create this diagram. Right now I've used 6. So what I'm going to do, I'm going to subtract from there, and we're left with 20 electrons to add in. Now the goal for everything, and by the way, feel free to ask questions. Please don't not be asking questions, okay? The goal for everything is to have 8 electrons. Right now, how many does sulfur have? What do you think?
Has 3. 6.
Does it have 3 or 6?
3.
It's got 6.
Why?
You're forgetting the key thing here, I guess, not remembering. They're not interchangeable, they're shared. So, like, these 2 electrons are shared with sulfur and oxygen. To give you another example, this is the same thing. Just because it's written like that, they're shared between both. So these 2 electrons go to sulfur and oxygen. These 2 electrons go to oxygen and sulfur. These 2 go to oxygen. You get the idea. So they're shared equally. Not really, but we'll talk about that next week.
So they both have 6.
No. So sulfur has 6. This oxygen has 2. This oxygen has 2. This oxygen has 2. Hey Ben, pay attention. Yeah. So yeah, relatively straightforward so far. I'm going slow on purpose. Now, we've got 20 electrons left over to add. So what we're going to do, we're going to put them around the oxygens, because everything wants 8. Now, we can only put 8 in for every oxygen, and we have to add them in pairs of 2. Always pairs of 2. So you go 1, 2, 3, 4, 5, 6. Can I add any more to that oxygen?
Bless you.
Yes or no?
No.
Why not?
This is already 8.
Because it's full. It's got 8 now. So you go then 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. All right. So I've added 18. We had 20. Subtract 18. We're left with 2 electrons, right? Now each oxygen has 8. We're happy. We have 2 more electrons, though.
Could you put it with the sulfur?
And sulfur has how many electrons?
6.
Do we see why it's got 6? If you have questions, please ask. So sulfur's, yeah, it's missing 2. Notice we have 2 left over, so you just go like that and you're done.
Would you only put the line if you were connecting it to another?
Yes. Drawing the line and the dots, there is a huge difference between a covalent bond and a lone electron pair. Like when we're doing molecular shapes, if this is a bond or a lone electron pair, it makes a huge difference.
So you just put the 2 dots by the middle one?
Yeah, that's it. And now sulfur's got 8. Each oxygen has 8. What? Ask. It's okay to ask.
How do you get 18?
From where?
Like from where? You
Like why did I subtract by 18?
yeah.
Because I added 2, 4, 6, 2, 4, 6, 2, 4, 6. That's why I literally counted adding the dots.
Wait, how did the O's have 8 though?
Because these
I
2,
know, but I thought they don't count. Like,
no, they do.
They do.
They don't count when you put it all together.
Yeah.
oh, they just don't count when you're like doing the 18 and you're putting it around.
Yeah, but we're talking net overall. How many now total does this oxygen have? It's got 2, 4, 6, 8.
So they're shared between the oxygen and
Yes.
So, for everyone, are we trying to get to 8 electrons?
Yep.
Are they always going to be filled?
Yes. The only exception is hydrogen. Stop. Just go get a non-wheelie chair. It'll be much better for everybody. So, any other questions on this, really? I mean, this is the first one. It's really not that bad. I mean, that's it. Once you have 8, you're done.
there's only 2 steps.
Oh, I kind of forgot to write the rest of the stuff. Sorry. Step 3 would be simply like, you see what I mean? It's more process than it is like steps. The step 3 would simply be add electrons to the outer atoms. Step 4 would be add electrons to the central atom, which is, if you think about it, we added to the outside, then we added to the central. And then step 5, if you're desperate, would be create double bonds, double or triple bonds, which I will show you an example about in a minute.
But doesn't it get like really complex? Like, let's say there was 2 sulfite, then it was.
What do you mean?
Like if there's two sulfite, you know, it's like SO3 right now.
Oh, I hear you. We're not doing that. Like those, just because there's, yeah, like I know what you're saying. We don't do that
Okay.
because like when you have sulfite bonding to something, it's bonding ionically. So those things aren't. You're not drawing Lewis structures for those then because they're not sharing electrons. So you can't do it like this.
Okay.
All right, let me show you another one here. All right, next example is methane, which is your warm-up question. So methane is CH4. I mean this one's pretty straightforward. So all you do, first thing you find the valence. Carbon's got 4, hydrogen has 1. How many hydrogens do we have?
4.
4, so a total of 8. There's no ionic charge. Methane's not an ion. So what you do here, central atom, you just go like that. I mean, do you see why carbon would be in the middle?
Yeah.
You also have to remember that hydrogen can never be a central atom, ever. Because hydrogen is the one exception. If you look in your notes, you'll see that H only wants 2 electrons. Ever. Ever, ever. What, Mo?
All you could do anyways.
Behind you, Mo. Mackie, did you want something? Oh, okay.
Isn't that all you could do anyways?
Yeah, that's it. I mean, because think about it. We just put in 2, 4, 6, 8 electrons, right?
You're done.
There's nothing else we can do. You subtract, we're left with 0.
Oh, it's impossible.
No, this is done. Because think about this. Carbon has how many?
I said it's impossible to break the rule.
Carbon has 4.
Yeah, the rule's never broken. Yes.
Carbon has 4.
Carbon's got 8. Remember that these count for, they both count.
So carbon has 8 and each hydrogen has 2.
If you want, until you get more comfortable with it, you can draw it like this if you want to sort of help you, so that you can see that they're both shared. So carbon has 8 because all those count for carbon, and each individual H has 2 because that goes there, etc. So methane's really simple. Like you see how you don't really need to do a lot of figuring for this one. It just kind of works out immediately. Yeah.
So these are all covalent bonds?
Always covalent right now.
So it only works with covalent?
Yes.
Because they share.
Yeah. Any other questions?
Where is it now?
That's it. You're done.
That's clear.
This is your final answer. Each hydrogen has 2. No, we look individually. This hydrogen has 2. This one has 2. I mean, yes, total there's 8 electrons on 4 hydrogens, but you guys split it up. Now, I want to show you one more, then I'll stop with this. Well, like this. I want to do carbonate, CO3, -2. And then we'll do cyanide too. Now, if you want to try doing this one, you just look at it and first thing, how many valence electrons? Carbon's got 4 plus oxygen has
2.
no.
8, 6.
It's got 6.
Times 3.
So remember, just for everybody that's not asking a question that has it, you've got 4 for carbon, you've got 6 for oxygen. Now you've got 3 oxygens, and then last but not least, do not forget, -2, you're going to add 2 more. Do not forget that. Because of that up there. What? If it's positive, you would subtract electrons, yes. So this adds up to 24?
Yes.
All right, okay. So 24 electrons. Now to start with, you draw out your structure. You go C, O, O, O. Pretty straightforward there. Questions to this point? All right. How many electrons did I just add?
6.
6. Good. So you subtract 6, you're left with how many?
18.
18.
Do you have to put dots in the lines?
What? No, you don't. I just do it to show you. You don't have to. Eventually, when you're like taking organic chemistry and you're drawing out, things with 50 lines, you're not going to want to put dots for them. Trust me. So next step, we've got 18 electrons. We're going to go around and we're going to add to the outer atoms now. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay.
Is it gonna fit every time?
Always. That's the point.
So what about carbon?
So, yeah. We have no electrons left over to add. You can't magically create some more with the wave of your Harry Potter wand, okay? You're just stuck with... What? Sure. You should ask her if she'll write another book about it. That's J.K. Rowling. Anyway. The way this will work now, you got 0 left over. Carbon doesn't have 8. That's a problem. So what you need to do, you need to say, well, there's a problem. Does oxygen have 8, though?
Yeah.
Does every oxygen have 8?
Yeah.
Yes. So what you need to do, you're going to, well, not you, but this oxygen, being all mature and friendly, is going to say, you know what, carbon, we're going to take these 2 electrons, and I'm going to share them between both of us. Now, just so we're clear, it could be from this oxygen, it could be this one, it could be this one. It does not matter.
But those are always added in.
What do you mean?
There's always 2 points on the electron line.
Just hang on. Watch. So this is what's going to end up happening. Does that answer your question?
Yeah.
Well, yes or no?
No.
What was the question?
Never mind. I think I got it.
Okay, listen for another second. You might. So what occurred here? This oxygen took its 2 electrons from here, and it said, you know what? I'm going to share it between both of us. Now, this oxygen still has 8 electrons because it's got 2, 4, 6, 8. These, remember, each of these bonds counts for 2 electrons. So right now, it's got 8. And if you look at carbon now, it also has 8 electrons because it's got 2, 4, 6, 8. These carbons still have 8, so they're good too. Does that bring up questions?
Makes sense.
I mean, it's like a puzzle. Your job is simply to put all the electrons you have in to get everything filled up with 8 electrons, except for hydrogen, and boron is another exception, but we'll talk about that later.
So you only do that if you don't have enough to add on?
Yes, like if we had no more to add. If we had had 2 more, we would have put 2 dots on the bottom of carbon, but we didn't. Okay? Now,
What if you have like 4 more?
you won't.
Oh.
Now, to answer one of your questions that I know some of you are thinking, like how do we know, or how does this work out in terms of, like why do we use this one? Why not this one or this one? So the way this works, take a look at the bottom here. I know this kind of looks out there. This is a really, really simple, basic example of a resonance structure. Now, below the line. Now, what that means, this is not really for this class, but what this means, like, this is the structure 1/3 of the time. Notice I didn't draw the dots in, by the way. After a while, you don't really draw the dots on the outer electrons. Let's just assume they're filled. But this is the structure 1/3 of the time. This is the structure 1/3 of the time. Notice the double bond has moved up to the top. Notice over here, the double bond has moved over to the right. It literally moves. Or, to keep it simpler, 1/3 of all carbonate molecules have this structure. 1/3 of all carbonate molecules have this structure, and 1/3 have this structure. Well, because there is no preference for which bond forms the double bond. So in a random, in randomness, you would have, with all, possibilities being equal, it's going to divide evenly. So 1/3, 1/3, 1/3. This is called a resonance structure. Just so you know, so in the future, if you ever see that.